this. Yeah. So yeah, I don't remember so the question was f was a function from disk to
Yeah,
disk,
yes.
and f of 0,
It's a,
f of half equals to 0. Okay. And what was
yeah,
the question?
okay, then which of the following are true? Like, if modulus of f dash of 1 by 2 is less than or equal to 4 by 3,
Uh,
uh, then next option is f dash of 0. Like, if f prime of 0 is less than or equal to 1 by 2,
uh.
then the both uh, first and second.
Oh, okay. So it was multiple choice correct, right? Or something like that. Let's see. I don't know. F both or was there
Yeah,
one more
both.
another option?
Like, I don't know, like, it was at this region, like, I don't know what.
Okay. Let's see. You so this is the thing?
Yes, yes. Yes.
Okay. Yeah, so what was our conclusion? We
We said option 2.
said option 2. Wait. 1 minute.
Yes.
We might have said option C, because what we know is fz is mod fz is less than z, less than mod z.
Yeah, yeah.
This was something which we proved, and
Yes.
right, and this implies that f prime mod f prime 0 is less than equal to 1. And so how did we say this? It also implies this, right? That the derivative everywhere is less than 1, right?
Yeah.
Right. So we said these things. Yeah. But I think you are saying that it will be less than half. This will be also true.
Um, okay.
Is that, I don't know, is that what you're saying? Or
Shubham, like, it is f dash of 0 is less than or equal to 1.
oh, that was the option?
Yes, yes, yes.
Okay, okay.
Less than or equal to 1.
Less than or equal to 1. Mhm. Right. Then,
So we
mhm.
concluded the second option is correct. Like we said that one.
Okay. But I mean, I would conclude that both are correct, right? Because uh, no, we also concluded that this is correct.
Okay. Okay.
Because as far as I remember, we concluded that this is less than equal to 1,
Yeah, yeah.
right? And that you can just prove directly.
Yes, yes.
Yes, that you can just prove. Yes. So then it's fine, I think, right? Just see if it is okay.
Okay, like how from here you're concluding f dash of 1 by 2 is less than or equal to 4 by 3? Like,
No, because I'm concluding this,
okay, okay.
and that you should try to prove. That I'm not proving. That is easy. That comes from Cauchy's theorem.
Yes, yes. Yeah.
Yes, but you were saying there is a lemma called Schwarz-Pick lemma.
Yes,
Right?
yes.
Yeah. So yes, I have heard that name, maybe we should just try to talk about that. So Schwartz. So this Schwartz lemma is a huge, I think, theorem. It's a very big. This is just a lemma, but it has big big versions in higher dimensional things and so on. But anyways,
Yes, yes.
yeah.
Yeah.
But
There are
I
so many versions of this, like,
yes. So maybe if you study something about this, you should tell me. Well, I don't know anything about higher dimensional things in this. Yeah, short speak. So can you tell me? I don't know the theorem, so if, just tell me the statement.
okay, like, okay, yeah. F is a, like, it is a map from D to D, like open disk to open disk.
Okay.
Then for all Z in D,
Hmm.
uh, the inequality modulus of F dash of, yeah, it's a holomorphic function, yes.
Huh.
Divided by
Okay.
1 minus
Hmm.
modulus of f of z, modulus of f of z
Okay.
square
Huh.
is less than or equal to 1 by
Hmm.
mod 1 minus modulus of z squared. Yeah.
Right. Yeah, I know this. This is a improved version of Schwartz lemma. Yeah.
Okay.
Right. Yes. This is an improved version of Schwartz. Right. But we will not bother proving it. It's not difficult. Right. So it is the Schwartz lemma only. You have to just apply an automorphism of the disk, which just does the appropriate thing. Yeah. Right. Is that what you do?
Yeah, like I did not see the proof, like,
No, don't see the proof. Try to prove it yourself. Okay.
okay,
So
okay.
yes, I mean, just think. What is it that you have to up? What do you have to do? So because it is just the Schwartz lemma, it's nothing, and just a coordinate change. Okay. So if you believe that for a and try, you see that it just comes. Uh, so you see the Schwartz lemma we know is this, which is very intuitive, and this, and then we concluded from here this thing, right? Now you want to prove this
Yeah,
thing. Okay, I might be wrong if it is just a coordinate change, but yeah. So you have this, and this clearly follows from that, but just a moment. So you have to, if you know the automorphisms of a disk, if you know all the automorphisms, then you can apply one of the automorphisms and do this. But which one I apply, I'm not sure. Okay, let's do it now. We should just do it. So let's try.
Isn't it coming from the simple calculation like
Hmm.
mod of fz less than equals to mod z, then minus then both, if we square the both side, it will be the same, less than equals to, and if we take the
Uh,
negative, then it will be greater than.
this one.
And again we, yeah.
Okay. So what do you say? You take this upside or something?
No, I'm just deducing this from these two inequality, which are by Schwarz
This two
lemma.
inequality. Okay.
And yeah, so mod of fz square less than equals to mod z square.
Hmm. Okay. It should
And
not come just like that, but okay. Let's see.
minus is greater than
Uh-huh.
if you take the negative.
Oh.
And if you reverse 1 by,
Oh
then it will
yeah.
be again.
Right, right. I understand. Okay. That's a bit surprising. But yeah, it is coming, so okay. Oh, really? Yeah. Is the question, I mean, yeah, it has to be correct because otherwise you would not be able to prove it also. Yeah. Then it is just this.
Yeah.
Okay. That was miss that. Yeah. Even though this is weaker than, but I think yeah. So this version has a lot of benefit. Okay. But yeah, we will not talk about it. So this is the theorem. Yeah, maybe there is a further improved version which might need some automorphisms. So, okay. So the thing about automorphism, which I just had in mind, if I would just share that, is number one, if you see, so tell me some automorphism of the disk which is not a rotation. There is this, I think, something like this, right? Is this is correct? Right? This is an automorphism. Or there is wrong. This not wait. This is not an automorphism. So of course we have rotations, but apart from rotations, you would like to know the automorphisms. Uh, the rotation fixes 0. There is a way. I mean, if you can use the upper half plane and apply the uh, biholomorphic map, then also you can do. Just wait. Yeah. Yes. So you take this and with the fact that with the condition that this is equal to 1, then this is an automorphism. So let's call this psi. Let's call this psi alpha. Okay, then firstly you have to check that psi alpha is from D to D. Let's check that. So that's just side calculation. Just check this. No, this is not good. This is something wrong I've written. Yeah, this is simply a constant, right? Okay, so let's try to figure out the automorphisms of the disk. Maybe should think and do it. So of course you have theta going to e to the power theta. Sorry. Yeah, of course you have the z going to e to the power I theta z, right? So these are there, these are rotations. Okay, what is the other class? Yeah, any idea? Yeah, I mean, we have all studied this at one point maybe, but now we don't remember it. So maybe we can take the help of this upper half plane, right? And see if that helps us. So there is this map, which you know, uh, z going to z minus I, right? Z plus I. This and this you can take that it's a biholomorphic map. Okay. So maybe we just call this, what should we call this? Maybe P. Okay. Now this clearly goes in the disk, so it's not a problem. And what is the inverse of this? We are going to use this. Okay, that will help us to figure out the thing. So we need the inverse. So what is the inverse? So if z is equal to w minus I, w plus I, then what is what? z plus 1, z minus 1, w by I. Right. So so wait, so what is the inverse? Is the inverse correct?
I think so. Like we will be getting wi minus I in denominator.
Okay, okay. So what is the inverse?
It's w plus 1
Uh,
by wi minus I.
okay, okay. So I wrote,
W
wait.
I
Yeah, so right, right, right.
okay.
So that's the same thing.
Like
Okay, so maybe yeah, wrote the other way. This right, same thing. Yeah, right. So this is the inverse. If so, let's just check it. So if this z goes to this, okay, and so if we say that, how do you find the inverse of a function? There is obviously the other way, but if you just try to do z goes like this, z goes to this, and if you call that this is equal to w, then wait, what? No. How do you find the inverse? Okay, then let's just do it. So we like so if G is the inverse, right? Then it's GZ and or maybe GW and then P of this should be equal to W. So GW minus I, GW plus I equals to W. So from here we find GW. Yeah, we took a long time. W W minus 1. So it should be W minus 1, right? That's what I'm getting. Right, that's what I wrote, I think. Okay, no problem. So this is W plus 1, W minus 1. Yeah, this is correct, right? Yeah. Okay, so this is the inverse. Yeah, the other way I was thinking of finding the inverse is if, so, I mean, I don't know. So if, yeah, so if I have applied f the function, and then I say that f of this is this, yeah, then I was just solving that, I was solving z in terms of that. And that would obviously give you the inverse, right? Because yeah, that function of W is the inverse function. But yeah, anyways, it was coming out to be the same thing, of course. So it is this. Now, how are we going to help? How is this going to help us? So, well, so you look at you can look at some automorphisms of the upper half plane. They might be easier. So if we take tau on the upper half plane to be, sorry, take tau on the upper half plane to be, yeah, I think I remember now. We have to take like this one. Now that I write it, I shouldn't have taken so long to think about this. But no, this cannot work. Okay, so this is tau, and tau is taking z to z plus 1. Okay, so now what you do, this is P, let's call this Q, or this P inverse basically. So then we are going to take, sorry, we are going to take this. And this is going to be an automorphism of the disk. Can we just quickly know what this is? So this is taking omega to I times omega, omega minus 1 plus 1. So this is, we applied Q and tau at the same time. Now you apply P. So we do it separately. I omega plus 1, omega minus 1, 1 minus I plus 1 plus I. Right, so we can simplify this. I omega plus I plus omega minus 1 minus I omega plus I. I hope it is correct. Minus I. Okay, and this is equal to what? This cancels. Okay, that's a very strange expression. But maybe it is not strange. 2I minus 1. We have to identify what it is. then maybe it will not be so strange. I and minus I cancel. So then there is omega minus 1. No, wait. So there is omega 2I omega minus 1, right? Is I I assume you have checked it. That would help me. Yeah, so but did not write that here. Sorry, so it is this so far. Now let us try to see if it is if it can be understood. So this is the thing, and this is omega. I think this is what I wrote. Similar to what I wrote. It's coming out to be this, and this is coming out to be this. Maybe. Yeah, so the mistake, but no, that was not correct. Right. Yeah, so I'm just not doing it correctly. Sorry. So there is a minus sign, and then there is 1 minus 2I plus 1 omega, right? Or is it not correct? It's not good. Okay, so this is omega plus this. Right, so it is, yeah, it is the same thing, conjugate omega, right? Now it looks better. Okay, now it looks better. So this tells us what to take as a generic thing. Maybe we'll just write it here in a different color and erase some of these things. Finally getting this. So what are we getting? We are getting this omega. This point is in the lower half plane. So this is alpha. And then or maybe, yeah, maybe I should take it in the upper half plane and put a minus. So we will take 2I minus 1. And then it is 1 minus this thing. So 1 minus alpha conjugate omega. Yeah, this is what we are getting. Okay. And this minus has to be replaced by, I suppose, again, e to the power I theta. That's I pi. That should be like that. Yeah, that is just a composition of that one. So we will not actually write it. We'll keep this in the as a primitive thing. But then we need a proper conditions on alpha, right? If alpha is in the upper half plane, then it's fine. Means, sorry, so if alpha is, so what should be the condition on alpha? We will be taking minus of alpha, so this means minus of this, so this is minus this plus 2y, so it is in the upper half plane, but uh, what should be the condition? So you see, this way we get all the automorphisms of the disk, but no, wait. They're doing something wrong. Yeah, so norm of omega should be at least 1. Yeah, that's all, right? That should be the condition. Norm of omega should be at least 1, and I suppose that norm of this should be greater than 1. Okay, because if it is equal to 1, then it is a constant function, right? And if it is less than 1, if it is less than 1, then it is not good, because the denominator will become 0 at some point. Okay, so please check it, and maybe next time tell me what are all the automorphisms of the disk, right? Yeah, and yeah, and then we can just maybe meet on Google Meet and try to see what there are some other questions we should try. But please, maybe you can give a more complete description of automorphisms. This is complete, but maybe you can interpret these things properly and tell. Okay. Yeah, so let's switch to Google Meet. A link is there already with you, so we'll use that. Okay.
Yes.
Okay.